Good morning, students. This is lesson number 5 of chapter Matter and Chemical Formulae. And today we are going to learn what is chemical formula, what is the use of chemical formula, what is valency, and how can we write down the chemical formula. So let us start.
Chemical formula. A chemical formula represents one molecule of an element or a compound. A chemical formula for a molecule is represented by the group of symbols of the elements which constitute the molecule along with the number of atoms of each element present in one molecule. The chemical formula for an element is represented by the symbol of the element followed by its atomicity in subscript. The number of atoms in a molecule of an element is equal to its atomicity. For example, hydrogen has the atomicity 2. Its chemical formula is H2. The chemical formula for a compound is represented by the symbols of the elements present, followed by the number of atoms of each such element in subscript. For example, the chemical formula for water, a molecule of which has 2 atoms of hydrogen and 1 atom of oxygen, is written as H2O. When an element is not followed by a subscript, it is understood that it has 1 atom in the molecule. For example, helium is written as He. So we can understand that it has only of chemical formula. The chemical formula of a compound represents one molecule of the compound. For example, H2SO4 represents one molecule of sulfuric acid. 2H2SO4 represents 2 molecules of sulfuric acid. A chemical formula represents names of the elements constituting the compound. For example, the elements constituting the molecule of sulfuric acid H2SO4 are hydrogen, sulfur and oxygen. Chemical formula represents proportion of atoms of different elements in the compound. For example, in a sulfuric acid molecule, the proportion of atoms of hydrogen H, sulfur S and oxygen O is 2:1:4. Chemical formula represents the mass of one molecule of the compound. For example, let us say we want to know the mass of a molecule of sulfuric acid, H2SO4. Then we can simply add the mass of 2 hydrogen atoms, 1 atom of sulfur and 4 atoms of oxygen to get the molecular mass of sulfuric acid. Valency represents the combining capacity of the atom of an element. When we take the valency of hydrogen as 1, then the valency of an atom or a radical may be defined as the number of hydrogen atoms that will combine with or be displaced by 1 atom of that element or radical. For example, water contains 2 atoms of hydrogen combined with 1 atom of oxygen. 1 atom of oxygen has the capacity to combine with 2 atoms of hydrogen. Therefore, the valency of oxygen is 2. Some elements may not combine with or displace hydrogen. In such cases, we consider their valencies in relation to some other element whose valency with respect to hydrogen is known. For example, the valency of chlorine is 1. One atom of sodium combines with one atom of chlorine to form one molecule of sodium chloride. Therefore, the valency of sodium is also 1. Valencies of most elements fall between 1 and 4. Elements with valency 1 are called monovalent. Valency 2 are called bivalent. Valency 3 are called trivalent, etc. Valencies are always expressed in whole numbers. Guidelines for writing chemical formulae. Let us study how to write chemical formulae. For writing the symbols of the two radicals, write the positive radical to the left and negative radical to the right. Write the valency of each radical at the top of the symbol. Divide the valency of each radical by a common factor, if any. Cross the valencies for the two radicals and place the numbers at the lower right side of each radical as a subscript. In case of a compound radical, enclose it in a bracket and place the number outside the bracket. For understanding more about this, let us write the chemical formulae for some radicals. Potassium sulfide. Potassium sulfide is made up of the radicals potassium K and sulfide S. For writing the chemical formulae, first write the symbols of radicals. They are K for potassium and S for sulfide, that is Ks. Write the valency of each radical at the top. K valency 1, S valency 2. Here, there is no common factor in valencies, so there is no need to divide them by any number. Cross the valencies. K1 S2 is crossed into K2 S1 or simply K2S. The formula is K2S. Calcium carbonate. The radicals of calcium, Ca, and carbonate, CO3, constitute calcium carbonate. Write the symbols of radicals, Ca and CO3. Write valency of each radical at the top. Ca valency 2, CO3 valency 2. Divide the valencies by the common factor. Here, common factor is 2. So, when we divide the valencies by 2, we get Ca valency 1, CO3 valency 1. Then we get CaCO3. The formula is CaCO3. Aluminium sulfate. In aluminium sulfate, the radicals are aluminium Al and sulfate SO4. For making the chemical formula, write the symbols of radicals Al and SO4. Write valency of each radical at the top. Al valency 3, SO4 valency 2. Here, there is no common factor in valencies, so there is no need to divide them by any number. Cross the valencies. Al valency 3, SO4 valency 2 is crossed as Al valency 2, SO4 valency 3. That is Al2 SO4 thrice. The formula is Al2 SO4 thrice.
So my kids, I hope you understood what we studied today. So based on that, here is your homework. Thank you. Have a nice day.